Hi everyone, my name's Matt Healey. I'm here to talk about Taiwan's emerging role as global leaders in the CCS industry. I'm really sorry that I can't be there in person today. Unfortunately, I'm on my way back to London, but even so, it's a real pleasure and a real honour to have this opportunity to be able to talk to you about this. I spent a lot of time in Taiwan. I spent a lot of time in Taiwan because of Taiwan's role as emerging leaders in the CCS industry. It's genuinely exciting what's going on here, not just from my sense as a CCS specialist based in London, but as a global sense for all of those CCS specialists based around the world. All of those people that I talk to are very interested in what's going on in Taiwan at the moment, and this is something that we can expect to be a large part of Taiwan's future as we all move towards net zero. Now, Taiwan has a goal to reach net zero of 2050. This is in line with many, if not most, industrialized nations. However, Taiwan does have some unique challenges. It will not surprise you to hear that Taiwan to go net zero is very different from the requirements say, in the EU or in the United States or in other countries in the region, such as Malaysia. CCS is a critical component when it comes to net zero. This is the case in Taiwan, and this is the case everywhere in the world. It is not the only solution. It is just one part. We are moving away from fossil fuels and towards renewables, and that is a key part of the move to net zero. We're also improving efficiency, and what that means is that we're able to do more, but by producing less CO2 and other greenhouse gases. This is also a key part. And then CCS is the key third part. We think of this as industry, we call it hard to abate. And what it means is industry where it's very difficult to stop that industry from producing carbon dioxide. Now, in Taiwan, an example of this is power. Right now, most power in Taiwan is produced from coal. We are ramping down coal globally and in Taiwan, and we're moving towards other hydrocarbon sources such as LNG, which are cleaner and more efficient, but still produce CO2. Taiwan can produce net zero power from LNG as these new power plants come online. Then we can have carbon capture, that's the CC in the CCS, and then we can dispose of that through carbon storage, which is the S part. This is the direction that Taiwan is going. Now, the first question is, what is this storage? Where does it go? So these are naturally occurring geological basins 2-3 kilometers below the surface of the Earth. And in fact, they're very similar to the geological basins that oil and gas come from. I like to think of them as having a concrete surface, something that if you spilled a cup of tea, it would just pool on top. Think about now spilling a cup of tea on sand. It absorbs into the sand. These naturally occurring reservoirs are quite simply a layer of a solid, like concrete, with a layer of sand that will absorb the CO2, with a layer of concrete at the bottom. It's as simple as that. We need this in Taiwan, as indeed we everywhere. We need the right geology for this. And in Taiwan, this is the west side of the country, the seismically stable geology. And of course, this exists in other countries as well. In fact, Taiwan's storage will be a mixture of these two. There will be some domestic storage in geologically stable parts of the country, and there will be export by ship to geologically stable parts in countries like Malaysia and Australia, which have very large-scale geology to store the CO2. Now, this is very similar to Japan, and in fact, there are a lot of great similarities between Japan and Taiwan as two heavily industrialized first world nations in East Asia. And so we have some very similar steps being taken towards net zero in Japan that we can look to, and we can see ways in which Taiwan and Japan are very similar. They are also phasing down coal to replace with LNG, and they're also looking at large-scale CCS to dispose of their CO2. Well, how much are we talking about? Well, right now, Taiwan is emitting in a year about 250 million tonnes per year of CO2. That's going into the atmosphere. We can't do that anymore. The CCS component of this, by 2050, will be about 40 million tonnes per year, with all of the other savings coming from renewables and efficiency improvements. If we compare this to Japan, well, they produce a lot of CO2 in Japan. In fact, they produce more than 1,000 million tonnes per year of CO2. That is over 1 billion tonnes per year. And their goal for CCS is about 1/4 of that. They're looking at pushing up to about 240 million tonnes per year of CCS as part of their net zero strategy. Now in Japan, we have 9 full-scale CCS projects. These are being funded by a government body called JOGMEC. Of these 9, we have 3 which are storing CO2 domestically, and that means geologically stable parts of Japan, and 6 which are exporting by ship to elsewhere in Asia. This is very, very similar to Taiwan's strategy with that mixture of domestic storage projects and CO2 export projects by ship. Like Taiwan, we're looking at Malaysia, Australia, Indonesia, maybe Thailand, maybe the Philippines, other geologically stable countries that aren't too far away. And already we can see one of the great advantages that Taiwan has got, and that is its geography, its location. It's close to these other parts of the world that have this capacity for very large-scale CO2 storage. So how do we ship it? And the answer is, it's very similar to shipping LNG. If you've ever seen those ships with the big bubbles on top of them, moving very, very large quantities of gas from where hydrocarbons are produced to where they're being used, shipping CO2 is very, very similar. The technology is quite straightforward. We simply liquefy the CO2, we put it into pressurized storage where it's held as a liquid, and then we ship it from one location to another. And so this is something that we can look forward to in Taiwan and indeed Japan, where we do have these very large CO2 transportation ships. This is going to bring work into the shipyards of the region as these CO2 ships are required. And of course, the harbour infrastructure will be required as well in Taiwan. This harbour infrastructure is actually one of the great advantages that Taiwan has in its route towards net zero. As you know, Taiwan has very concentrated industry around its harbours in parts of the country, in the north, in the centre, and in the south. And the proximity of this industry, not just to itself, which means that the sources of CO2 tend to be located very close to one another, but they also tend to be located very close to the harbours. And that makes the transport of CO2 from the source to the point where it goes onto a ship quite cheap and quite simple and much easier than many, many other nations, including the UK where I'm from. It makes the logistics of this a lot simpler. And so what we have here with Taiwan is we have a similar problem to Japan in terms of the need to dispose of CO2, and we've got these 3 great advantages. The first is significant domestic storage capability. The second is the location of Taiwan in Asia and the proximity to the very large-scale CCS storage projects in places like Malaysia. And then thirdly, that concentrated industry near harbours. It takes the transportation of that CO2, it makes it cheaper, it makes it simpler. We've also got in Taiwan a world-leading project which will be starting up in the not-too-distant future. This is CPC's Tia Chen Mountain project. This is a trial project for carbon storage where we are transporting CO2 in quite small quantities by truck, and then we're disposing of it at the storage location. Now, this is a small-scale storage project. It is largely a learning project. It will not make a significant difference to Taiwan's CO2 emissions, but what it is a world first. This is a really exciting project. I'm really proud to say that the company that I run, PaceCCS in the UK, has been involved with this project. We've been working with CTCI to help build and start up this project. And of course, it's CPC's project that is who we're working for. It is a fantastic project Firstly, because it will be, we think, the first operating project where we're disposing of CO2 from road tankers. I say we think because there's a Danish project which is on a similar timeline. So there's a bit of a race going on. But what's important is that we've got road tanker storage and then going from the road tanker to disposal, which is absolutely a world first and the only project in the world anywhere near operations that is starting up. It's also an uncommonly low risk project. Now, I'm an engineer. We talk about risk, and no one likes it when I talk about risk because it sounds like there might be things going wrong. But what's great about this project at such an early stage of this CCS industry, remember those hundreds of millions of tons of CO2 that we're going to be disposing of and transporting by ship around Asia. This project is really simple and really robust. And what it means is that this creates a model for CCS projects all around the world. Now, even though this is small scale, the concept can absolutely be turned into large scale. And in fact, there are projects around the world that are looking to the Taiwan Mountain CCS project as an example of what they aspire to. This is especially important when you have decentralized sources of CO2. So that might be a power station up in the mountains somewhere, and where you don't have access to harbours as conveniently as we have for most of our sources of CO2 within Taiwan. So I can tell you that when we are working with people around the world, we look at this project, and we've looked at it recently with projects in Austria, where they have lots of industry, but they do not have the convenience of either the geology nor the harbour storage. And so we look to the Taiwan Mountain project as an example, as something that they can aspire towards. We see it in Canada as well. Now, Canada has lots of potential for CO2 storage, but not necessarily located close to the industry around the country. And finally, India. India is a nation that doesn't have large-scale pipeline infrastructure. It has lots of industry spread out around the country. And so the question is, how do we decarbonise that? And these three countries, Austria, Canada and India, they've got one key thing in common with Taiwan, and that is the historical reliance on coal for energy. Despite the fact that we think of these as being three very different nations to Taiwan, they are all looking to CCS in Taiwan because the problems that have already been solved here are problems that they are facing. And they are a few years behind, but they can look and they can learn, and we can fully expect, in fact, the world visiting Taiwan once this project starts up to observe it and learn from it. Now, this is an example where Taiwan is very much world leaders when it comes to CCS, but it's not just in the projects themselves, it's also in the technology. I have the real pleasure to talk to you very briefly now about a CCS technology project that we at PaceCCS are working on. We have a project with Foxconn, who are obviously based in Taiwan. And what we are doing is we are looking at a challenge facing the CCS industry. I hope you'll forgive me for giving a short technical introduction, because the technical stuff is what's really interesting. It's what's the fun part about the work that I do. So those of you who are less interested in the technical stuff, I don't mind. You don't need to listen to this maybe quite as closely, but I really hope you do, because it really is interesting. When we build things out of steel, we're worried about corrosion. This is the case whether you're building a bridge, whether you're building a pipeline, whatever it happens to be. Now, CO2 is not corrosive. However, some of the impurities that can be present in the CO2 are. One example is water. When we take CO2, it's completely non-corrosive, but if we add water, the water and the CO2 interact and we produce carbonic acid. We produce sparkling water. This sparkling water is slightly acidic. It's one of the reasons why it's so delicious. But this acid can be corrosive to carbon steel. And there are other impurities, non-water impurities, that are sometimes present in CO2 that can lead to corrosion. Now, these impurities are actually pretty common in the industries that we need to decarbonise using CCS. And so now we have one of these fun technical problems. How do we manage this? How do we make sure that our CO2 is non-corrosive, but also allowing it to have these impurities being present? We can remove these impurities if we need to, but this costs money. What we'd like to do is find a way to allow us to have relatively impure CO2. And impure in my world, by the way, is a minimum of about 95, 96%. So it's still very pure, but it's that extra 1 or 2% of stuff is where the impurities can come along. And so what we've done is we've learned a lot from Taiwan's industry and the CO2 that's already being used by companies like Foxconn in their industrial processes. And we've realised that knowledge that they have and experience that they have in that absolutely enormous company, we can apply this to the CCS industry. We can take knowledge that already exists and skills that exist in Taiwan, and we can adapt them and apply to CCS. What this means, and we believe, that we can take processes used in Taiwan by Foxconn and others, and by applying it to CCS, we can solve this corrosion issue, and we can reduce the cost of CCS everywhere, all around the world. We're building a laboratory. In fact, by the time you're listening to this, I'll have gone to see the laboratory. We'll be starting up later this year, and we'll be running a program to show that our theory, which we're very confident about, works in the real world. Now, this is technically of technical interest, but this is of great commercial interest to Taiwan, because we have got hundreds of CCS projects around the world to whom this is relevant. And I'll give you one example. That one example is the Porthos project, which is in the Netherlands. The Porthos project has very large scale carbon dioxide capture in industry around Rotterdam. They compress the CO2, they put it into a pipeline. This pipeline goes offshore into the North Sea, and then the CO2 is disposed of into an old oil and gas reservoir in the North Sea. Now, this project is due to start up in a few years' time. In fact, it's currently under construction. And as part of the engineering, which we're involved in, they're looking at this potential for corrosion as a result of these impurities. The Porthos project, which involves many large European energy companies, the Dutch utility company EBN, GasUnie, Total, and others, their technical team have looked at what we're doing, and they agree that this is an incredibly promising emerging technology. They have written us a letter of support, which I'm pleased to have been able to share alongside Foxconn as an example of the industrial support that we've got for this incredibly important technology being developed here. The reason why I'm here in Taiwan is because this is something that could not be done anywhere else in the world. The combination that Taiwan has with its forward-thinking approach towards net zero, with all of those advantages that I talked about before, and of course the industry here with the knowledge that we can adapt to CCS, creates a situation where we can work in Taiwan to deliver things on a genuinely global sense. This is obviously quite early. Taiwan's plans for 40 million tonnes per year of CO2, well, that's 2050. That's 25 years away. Now, 25 years is a long time, but when you're building things which are very large scale, it's not really that long at all. An awful lot is going to happen. An awful lot has happened in Taiwan in the last 25 years, and an awful lot of industry will build up in the following 25 years with CCS as a component. What we can do is, I'd just like to finish off by looking into the future and seeing what Taiwan's CCS industry may look like at that time. Because it's not just going to be the CO2 capture and disposal, it's going to be that transition away from coal and towards LNG. It's going to have domestic CO2 storage at a large scale, not just our Te Chen Mountain CCS storage pilot project. We're going to have, it's It's going to be a hub for CO2 shipping. Taiwan will become a hub for Asia because of the CO2 that is going to be transported out of out of Taiwan and possibly into Taiwan, depending on the outcomes of Taiwan's CO2 industry. It may even become an import terminal for CO2 elsewhere. And more importantly, and most importantly, it's as those global knowledge leaders. All of this work that's being done today, all of this technical stuff being done by, nerds like me, all this knowledge that already exists in Taiwan is going to grow, and it's going to mean that Taiwan is going to become not just a leader in Asia when it comes to reaching net zero, the fight against climate change and carbon capture and storage, but a global leader. Thank you for your time. I'm sorry I can't be there to answer any questions directly, but of course, please, if there's any follow-up, I'm more than happy to be contacted. Thanks very much.